नेक्स्ट, अब हेडिंग लिख लो टाइप्स ऑफ वेक्टर्स। आज का हर लेक्चर में डेट लिख लो, ठीक है, और हर लेक्चर में डेट से शुरू करो। ओके, सो अब हेडिंग लिख लो टाइप्स ऑफ वेक्टर्स। फर्स्ट ऑफ ऑल ज्योमेट्रिकली देखो, मैं बहुत कुछ कट शॉर्ट करके आगे बढ़ रहा हूं, तो मैं थोड़ा फास्ट तरीके से ही जाऊंगा, ठीक है। सो फर्स्ट ऑफ ऑल मुझे ये बताओ कि एक वेक्टर को हम ज्योमेट्रिकली कैसे डिनोट करते हैं। वी डिनोट अ वेक्टर बाय अ एरो, और जो पीछे का होता है उसको हम टेल कहते हैं, और जो एरो जहां होता है उसको हम हेड कहते हैं, ठीक है। और ये वेक्टर जो है हमें बता रहा है कि द डायरेक्शन इज फ्रॉम ए टू बी, है ना। और दूसरा हमें इस ज्योमेट्रिकल रिप्रेजेंटेशन में ये भी, दिस ऑल्सो इज इंपॉर्टेंट, दैट द length of the line that we are showing represents the magnitude of the vector. समझ रहे हो क्या? Is this clear? So the easiest thing to figure out is, let's say, displacement. So one person is moving from A to B and he moves for 10 kilometers. So the length that we usually show corresponds to the magnitude of that physical quantity. Okay, that means we are showing this length as 10 kilometers अगर मान के चलो। Okay, now another person has walked in the same direction for 20 kilometers. So how will I draw? First, in the same direction means it should be parallel, ठीक है, and the length of this should be twice. This is 20 kilometers. Is this clear? Yeah. So for displacement it's a very obviously understood thing, but it applies for all physical quantities. For example, it applies for force. The length of the arrow that we show represents the magnitude of the force that is acting, or acceleration, or any physical quantity which is there. So the length is representing the magnitude of that particular physical quantity. Clear? Now if अगर ये 10 न्यूटन है पहला वेक्टर, 10 न्यूटन is the unit of force. If another fellow is applying twice the force, that is 20 newton, then I will represent his vector with 2 times the length of AB. Is this clear? Yeah. So first, geometrically we need to understand that the arrow is denoting the direction of that particular physical quantity, and the length of the line is denoting the magnitude of that particular physical quantity, and it can be actually compared with one vector to another vector to another vector. So 10 kilometers is this much, 20 kilometers is twice of it, 40 kilometers is 4 times of it. Is this clear? Yeah. Now this is geometrical representation. Now coming to the first type of a vector. Okay, so let's say parallel vector. तो आप बताओ कि आपको what according to you are parallel vectors? So the above example is parallel vector. Haji? Those two are basically parallel vectors. So if you want to generalize which vectors are parallel vectors, how would you do so? The direction which are parallel, the direction which are adjacent to each other. The two vectors which are having same direction are called parallel vectors, right? Parallel vectors में we don't worry about the magnitude part of it, but the direction has to be same, correct? Is this clear? Yeah. Anti-parallel vectors means opposite direction. Okay. Why we are discussing parallel or anti-parallel is because in the question he will just say the two forces which are acting anti-parallel to each other. That means we will basically see that the directions of both those forces are opposite to each other. Clear again? So in this case we can use the above example that the AB bar is basically parallel to CD bar. और वही अगर एंटी पैरेलल वेक्टर्स हैं तो मैं कोई वेक्टर ए बी बार यूज करूंगा. आई विल यूज सम ई एफ बार विच हैज ऑपोजिट डायरेक्शन. ओके. फाइन. एक है इक्वल वेक्टर्स. नेक्स्ट वाला है इक्वल वेक्टर्स. व्हाट आर इक्वल वेक्टर्स?
Which have equal same magnitude, same direction.
Same magnitude and same direction, है ना? So equal vectors are vectors which have same magnitude and same direction. So basically, if I have some AB bar and same length and same direction, if I have another vector, let us say GH bar, then equal vectors, mathematically I can write that AB bar is equal to GH bar. Correct? ठीक है. Now we can also represent a vector with small alphabet. Okay, let's say A bar. ठीक है. If this is a vector a small a bar, then I can treat this vector as 2a bar. Why? Because it is twice the magnitude and also parallel. Clear है क्या? Now, for equal vectors, if I will say that this is p bar, then I can call this fellow as also p bar. Basically, my p bar is nothing but AB bar, which is GH bar. Is this clear? That means there are two people applying force on wall in the same direction with the same magnitude. So in that event, दोनों forces अलग-अलग है, right? Actually, practically, there are two people applying forces, but the magnitude and direction of those forces are the same. Is this clear?
Yes.
ठीक है. चलिए, अब मुझे बताओ कि what is a null vector?
Having no direction.
हाँ जी.
Having no magnitude. Having no
हाँ.
magnitude.
Having no magnitude. So the magnitude of the vector should be 0. Any vector which has 0 magnitude is called null vector. Geometrically, we can represent it by a point, by a dot. Now tell me, how what about the direction of a null vector? Does a null vector has a direction?
Yes.
Okay, so which direction does this null vector has?
Horizontal.
A point denotes infinite directions. Are you getting my point? See, कहने का मतलब ये है कि I am applying a force of 0 Newton. Okay? I am applying a force of 0 Newton. Means if I apply any force, I can choose any direction. Are you getting my point? I can choose any direction to apply force. Clear?
Yes.
So till here let's say parallel, anti parallel, equal, null वेक्टर, ये सारा जो है इंपॉर्टेंट तो है, लेकिन बहुत ही ज्यादा इंपॉर्टेंट है यूनिट वेक्टर। इसमें इसमें बहुत सारा काम निकलता है सिर्फ एक छोटे से डेफिनेशन से। व्हाट इज अ यूनिट वेक्टर?
Having one direction and one magnitude.
हैविंग वन मैग्नीट्यूड, डायरेक्शन का कुछ जरूरत नहीं है, द मैग्नीट्यूड ऑफ द वेक्टर इज वन। ओके,
Direction unlimited.
डायरेक्शन तो उस पर्टिकुलर सिचुएशन पे डिपेंड करता है कि मैं अगर 1 न्यूटन फोर्स इस बोर्ड पे लगाया या फिर 1 न्यूटन फोर्स हवा में लगाया, डायरेक्शन इज बेसिकली द डेफिनेशन डजंट से एनीथिंग अबाउट द डायरेक्शन, वो कहानी है। द डेफिनेशन डजंट से एनीथिंग अबाउट द डायरेक्शन, ठीक है। Definition says only one thing, that its magnitude is 1, and that 1 can be anything, 1 kilometer per second, 1 kilometer per hour, 1 meter per second, 1 meter, 1 newton, वो फिजिकल क्वांटिटी कोई भी हो सकता है, लेकिन 1 होना चाहिए उसका मैग्नीट्यूड, देन वी कॉल इट एज यूनिट वेक्टर। ओके ओके, a unit vector is denoted by a small alphabet and with a cap on it, जैसे कि ये हो गया n cap। A unit vector is denoted by a small alphabet with a cap on it. Is it clear? And mathematically, how I define unit vector is n cap is equal to the vector n bar divided by the magnitude of the vector. कहने का मतलब है take any vector and divide it by its own magnitude, you will get the unit vector in that particular direction. A unit vector n cap mathematically is defined as vector n bar divided by magnitude of n bar. So you take any vector, okay? You take any vector and divide it by its own magnitude to get the unit vector in that direction.
Magnitude is usually denoted by mod.
Magnitude is denoted by the modulus thing.
Yeah.
Welcome to mathematics. ठीक है? This mathematical definition is important. Why? Because now I can rewrite the same thing as, I can write any vector as, इसको cross multiply कर लो, the magnitude of that vector times the direction of that vector.
Yeah.
Okay? ठीक है? और एक और important point, very important point over here. What is a unit vector mostly used for? Unit vector is mostly used to denote the direction. Is this clear? The definition of a unit vector says that the magnitude of the unit vector is 1. Okay? The definition of the unit vector says that the magnitude of it is 1. But so many things come out of it. And the unit vectors usually are denoted to represent the direction of the vector. समझ रहे हो? अब मैग्नीट्यूड तो 1 हो गया ना भाई, तो फिर उसमें और क्या बचा है? डायरेक्शन ही बचा है। समझ रहे हो? मैग्नीट्यूड तो 1 हो गया, मैंने बोला है यूनिट वेक्टर, यूनिट फोर्स वेक्टर, फिर यूनिट एक्सेलरेशन वेक्टर, यूनिट टॉर्क वेक्टर, यूनिट फील्ड वेक्टर। मैग्नीट्यूड तो सबका 1 है, एक बार यूनिट बोल दिया तो मैग्नीट्यूड इज 1. Then what extra is it telling me? It is basically telling me the direction of these vectors. In fact, उसको extra नहीं बोलूंगा मैं बोलूंगा mainly it is used to denote the direction of the vectors.
What is used to denote?
Unit vector is used to denote the direction of a vector.
Magnitude denote ना कि एक magnitude है.
क्या 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 मैग्नीट्यूड तो 1 हो गया ना.
हाँ तो यूनिट वेक्टर.
मैं कह रहा हूं a unit vector is a vector whose magnitude is 1. तो अब मैग्नीट्यूड के बारे में कुछ बात करने का है ही नहीं. मैग्नीट्यूड 1 है. ग्रेट. अब और क्या बचा है बात करने के लिए? डायरेक्शन. तो किसी भी यूनिट वेक्टर को हम मेनली यूज करते हैं टू डिनोट द डायरेक्शन, क्योंकि मैग्नीट्यूड तो 1 है ना. और ये चमत्कारी हम नल में यूज नहीं कर सकते क्योंकि वो तो शून्य कर देगा लाइफ. We can use a unit vector to denote the direction of vectors because anyways magnitude is anyways 1. Is this clear?
Okay.
And if you look at this way of writing that vector, अब इसी को मैंने क्रॉस मल्टीप्लाई करके ऐसे लिखा, so you can say a vector can be denoted or a vector can be written mathematically as a product of its magnitude and direction. समझ रहे हो क्या? When I am multiplying magnitude with n cap, I am saying it will tell me the entire vector. That means somehow I am starting to use my unit vector to represent the direction of vectors. The main usage of unit vector is to denote directions. So हमने mathematically define कैसे किया? n cap is equal to n bar divided by mod n bar. ठीक है. अब मैंने इसको क्रॉस मल्टीप्लाई किया तो ओरिजिनल वेक्टर n बार कैन बी रिटन एज, ये उधर चला जाएगा, मैग्नीट्यूड ऑफ n बार इनटू n कैप. ये तो हो गया आपका पूरा का पूरा वेक्टर. इसको आप बोलोगे वेक्टर. वेक्टर का मतलब क्या है? मैग्नीट्यूड और डायरेक्शन दोनों भी है. अब मॉड्यूलस वाले चाचा को हमने क्या बोला? ये हो गया हमारा मैग्नीट्यूड. अगर ये हमें मैग्नीट्यूड बता रहा है और आपको पूरे के पूरे वेक्टर के लिए मैग्नीट्यूड के साथ साथ डायरेक्शन भी चाहिए, तो ये आपको क्या बता रहा है? डायरेक्शन बता रहा है. The main usage of unit vector is to denote the direction part of it. मैं आपको एग्जांपल्स देता हूं. और सपोज देयर इज अ वेक्टर PQ बार. अब देखो हम लोग वेक्टर्स डिस्कस कर रहे हैं, so this applies to any vector, force, field, है ना. कल हमने जो एग्जांपल्स डिस्कस किए वो सारे फिजिकल क्वांटिटीज पे अप्लाई. टॉर्क, एक्सीलरेशन. we have shown a vector PQ bar. Specifically I will give an example that there is a person called Chandu, and Chandu is walking from P to Q for 10 kilometers towards east. ठीक है. So 10 kilometers towards east is telling you the entire description of the displacement vector, correct? In which 10 kilometers is your magnitude part of it and east is your direction part of it. ठीक है. Now अब मुझे यार ईस्ट वीस्ट के चक्कर में बात नहीं करना है. मुझे बात करना है मैथमेटिकल टर्म्स में. I don't know what east is. I only know mathematics. मैंने सोशल स्टडीज पढ़ा नहीं है स्कूल में. तो डायरेक्शन जो है ईस्ट, उसको हम PQ कैप करके भी रिप्रेजेंट कर सकते हैं. अब ये तो हो गया एंड पॉइंट्स के हिसाब से लिखा ना अपन ने, PQ बार, PQ कैप. अब मान लो इसको मैं स्मॉल अल्फाबेट के हिसाब से लिखूं तो मैं लिखूंगा लेट्स से L बार. ठीक है. L is the small alphabet और उसके ऊपर जो बार है वो रिप्रेजेंट कर रहा है कि ये पर्टिकुलर चीज वेक्टर है, राइट। तो अब ईस्ट को मैं एल के टर्म्स में कैसे लिखूंगा, एल कैप। अब आप बोलोगे नहीं भाई मुझे ये 10 किलोमीटर टुवर्ड्स ईस्ट ऐसे मत बताओ, थोड़ा हीरो बन के बताओ। तो मैं बोलूंगा माई वेक्टर एल बार इज इक्वल टू 10 एल कैप और इसके यूनिट है किलोमीटर। समझ रहे हो क्या? बेसिकली व्हाट आर वी डूइंग, वी आर describing our entire vector as magnitude part of it times the direction part of it. That means this L cap is telling you, is representing the direction part of it. समझ रहे हो? Any vector has to have someone to denote its direction. One way to denote direction in our human perspective is सीधा चले जाना, फिर राइट मार लेना, फिर लेफ्ट मार लेना, वहां चाय की दुकान मिलेगी, उसके ऑपोजिट में एक जनरल स्टोर होगा, वहां से राइट के गली में सीधा चले जाना, और तीसरा शॉप मेरा है। गुड मॉर्निंग।
Okay, I got it.
कौन से ख्वाब में चली गई थी?
Now I understood.
मैं कह रहा हूं कि one way of looking at directions is north, south, east, west. The other way of looking at directions is unit vectors.
The cap.
Cap. The cap fellow basically is nothing but the mathematical representation. North, south, east, west is a very generalized representation. एंड हाँ, और नॉर्थ साउथ ईस्ट वेस्ट जो है अपने को 2D में आएगा, फिर अपन अप डाउन भी बोलेंगे। समझ रहे हो क्या? और अगर धरती में है तो नॉर्थ साउथ ईस्ट वेस्ट एक्चुअली फिक्स हो गया, मैं नॉर्थ को अपने हिसाब से बदल नहीं पाऊंगा। वही अगर मैथमेटिकल टर्म्स में अगर बात करूं तो मैं अपने हिसाब से बदल सकता हूं। आई विल शो इट टू यू नाउ। पहले इस एग्जाम्पल को लिख लो। यूनिट वेक्टर बहुत ज्यादा इंपॉर्टेंट है। हेलो एवरीवन, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, NEET UG and other competitive exams. If you are interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. For class students, we do the entire derivation, but I am not doing the derivation over here. I am just directly telling you important points. Okay, suppose I have two vectors a bar and b bar. Let us say this vector is a bar and this vector is b bar, and the angle between two vectors is theta. First of all, most common mistake हम ये करते हैं, when we want to identify the angle between vectors, we make a lot of mistakes. So what is the mistake that we do? So nahi, whenever you want to check angle between vectors, always place the tails of both the vectors at same point, and then the angle between lines, shortest angle between lines, will tell you the angle between vectors. I mean, I can give you a question in which I can draw a geometry and easily confuse you, so that instead of substituting the right angle, correct angle between the vectors, आप substitute कर दोगे wrong angle. It's very easy to basically get mistaken. Clear है क्या? So ये statement को लिख लो. Point number 1. Whenever we want angle between two vectors, लिख लो. Always place the tails of both the vectors at the same point, always place the tails of both the vectors at the same point, and the shortest angle between the lines will represent the angle between vectors. The shortest angle between the lines will represent the angle between vectors.
What is angle between the lines?
Between the lines will represent the angle between the vectors. Done. I can show these two vectors this way, or I can also show these two vectors this way. I mean, first I will draw a bar, and then I will take the tail of the vector at the head of the a bar. Tail of B, I will place it at the head of A. And if you will see, this angle will basically be theta, correct?
Oh.
Fine. First question is, can I shift any vector like I shifted B bar? From here I shifted it to here.
The parallel equal vectors.
They are both equal vectors, correct? So मेरा second point ये है आपको बोलने के लिए, you can shift any vector in, रुको पहले इसको statement को समझो. You can shift any vector in the 3D space if you are not changing its magnitude and its direction. मैं बोला रही वो देख कौवा है, अब मैं यही चीज ग्राउंड फ्लोर से भी ऐसे ही बोल सकता हूँ, वो देख कौवा है. मैंने डायरेक्शन चेंज नहीं किया और मैग्नीट्यूड भी चेंज नहीं किया, बस मैं अपने आप को चेंज कर रहा हूँ. मैं इस कमरे से बोल रहा हूँ, फिर बगल वाले कमरे से बोल रहा हूँ, फिर नीचे जाके बोल रहा हूँ, चाहे कहीं से भी बोलूं मैं. My magnitude, that is the length of the vector, and the direction should not change. समझ रहे हो ना? लिख लो second point. You can shift, you can shift a vector anywhere in the 3D space. You can shift a vector anywhere in the 3D space. You can shift a vector anywhere in the 3D space if the magnitude and direction are intact. ठीक है? So this vector, इसको मैं यहाँ शिफ्ट कर लिया, वहां शिफ्ट कर लिया, कहीं भी हवा में शिफ्ट कर लिया. Not only in 2D, in 3D I can shift anywhere. I should make sure that the magnitude and the direction of it are intact. Then I can shift it anywhere. Clear है क्या? And like you said, this B bar and that B bar both can be said as equal vectors actually. Similarly, if I draw this A bar over here, exact fit होगा, और इसी को हम parallelogram law of vectors भी बोलते हैं.
हाँ.
Clear है क्या? Now, the third point which usually people face trouble is that when you are adding two vectors, when you are finding the angle between vectors, you should place the tails of both the vectors at the same point. When you are adding two vectors, always place the tail of the second vector at the head of the first vector. Always place the tail of the second vector at the head of the first vector, and the line joining the tail of the first vector to the head of the second vector is called as the resultant vector. समझ में आया? I'll repeat again, बाद में dictate भी करूंगा. So पहले क्या बोला मैंने, if we want to find the angle between vectors, place the tails of both the vectors at the same point, and the shortest angle between lines is the angle between those vectors. Clear? If we want to add the vectors, for addition of vectors, place the tail of the second vector at the head of the first vector, and the line joining the tail of the first vector to the head of the second vector is called the resultant vector. Clear? मैं पहले डिक्टेट करता हूँ, बाद में ये सब ड्रॉ कर लेना. थर्ड पॉइंट, for addition of vectors, always place, for addition of vectors, always place the tail of the second vector. For addition of vectors, always place the tail of the second vector at the head of the first vector, and the line joining and the,
first vector.
always place the tail of the second vector at the head of the first vector. Head, okay, at the head of the first vector, and the line joining the tail of the first vector and the line joining tail of the first vector to the head of the second vector is called as the resultant vector. Is called as the resultant vector.
Around the tail of the first vector is called the resultant vector.
ठीक है? And the line joining the tail of the first vector to the head of the second vector. Line joining tail of the first vector to the head of the second vector is called the resultant vector. ठीक है? कर लो, दिल खोल के यौन कर लो. क्या हो गया, नींद आ रहा है?
नहीं.
चलो देखो. So theta is what? Theta is angle between A bar and B bar. ये अपना फर्स्ट पॉइंट था. ठीक है, जो भी हमेशा याद रखना, जो भी मेरे बोर्ड पे रहता है वो आपके नोट्स में रहना चाहिए. कुछ भी गायब हुआ तो बहुत सारा प्यार मिलेगा, फिर उस प्यार को आप झेल नहीं पाओगे. ठीक है? सो पहले अपन ने क्या बोला, थीटा इज द एंगल बिटवीन ए बार एंड बी बार. अब वो एंगल पता करने के लिए टेल्स को जोड़ना है. फिर हमने क्या बोला, जब हम ऐड कर रहे हैं तो विल प्लेस द टेल ऑफ द सेकंड वेक्टर एट द हेड ऑफ द फर्स्ट वेक्टर, एंड द लाइन जॉइनिंग द टेल ऑफ द फर्स्ट वेक्टर टू द हेड ऑफ द सेकंड वेक्टर इज द रिजल्टेंट वेक्टर. इसका मतलब है कि ये जो है इसको मैं रिजल्टेंट बोलूंगा. ठीक है? Resultant also in general words means that it is the net effect of the all the vectors. Net effect. ठीक है? अब देखो, now I can write this addition of vectors in this way: AC bar is equal to AB bar plus BC bar. Clear? I can also write it in terms of small alphabets which are representing C bar is equal to A bar plus B bar. Okay? ठीक है? Also, whenever we are representing the vectors with small alphabets, that means the magnitude of it is nothing but the small alphabet itself. That means magnitude of small a bar is A, magnitude of small b bar is B, magnitude of small c bar is equal to. Is this clear? Now, if I want to talk about only the direction magnitude part of it, so I can write C is basically A square plus B square plus 2ab cos theta. This is where substitution of theta is required, and this is where mostly we face the problem. Clear है क्या? ठीक है? अबे हाँ ना बोल.
हाँ
ठीक है?
वो तो से कर गया
Next, see, we only know the magnitude of C bar right now. We still don't know the direction. If we know A, B, and theta, that means we know C, right? C is nothing but the magnitude of C bar.
yeah
To find the direction, I will say let the angle between C bar and A bar be alpha, okay? And we can find the angle by using tan alpha is equal to B sin theta by A plus B cos theta. Okay? क्या हो?
okay
अब कुछ तो लिख दिया है, क्यों लिखा पता नहीं है ना. See, मैग्नीट्यूड क्या आपको याद है कि मैग्नीट्यूड कैन बी रिटन एज स्क्वायर रूट ऑफ a square plus b square plus 2ab cos theta?
no
Okay. See, there is a derivation for it, but I am suggesting that you will eventually. टाइम नहीं है ना,
okay
समझ
so
रहे हो?
magnitude is
Most of the cases you will not be using these things much. Most of the cases you will be using something else. I just want you to know if the magnitudes of the vectors are known and the angle between the vector is known, you should know that you can find the magnitude of resultant and the direction of resultant. That's all. I
that's
just
the
want you to know this much. For example, if it is given magnitude of A bar is equal to 3 units, magnitude of B bar is equal to 5 units, and the angle theta is given as 60 degree, then he will say find the magnitude of C bar and also find the tan alpha. मतलब magnitude of C पता करो, direction पता करो. That is what he is saying. Understood? Find the magnitude and direction of the resultant vector. Is this clear? आप पहले इसको छापा मारो, फिर इस एग्जाम्पल को लिख लो, फिर इन चीजों को वहां सब्स्टिट्यूट करके देखो कि आंसर आ रहा है क्या. ठीक है? Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share, and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.